Welcome to Laws of Exponents recap. In this video, we're going to go over a few rules of the laws of exponents with the product rule, the quotient rule, power to power rule, and zero exponent rule. So in the first example, we have something times something. That would be the product rule. And for the product rule, you multiply coefficients, and then you keep the base and add the exponents. So right now my coefficients are -3 and 5. So -3 times 5 would give me -15. Now I'm going to move on to my next variable. The next variable is x. Now these are bases because they have exponents, whereas my coefficients didn't have any exponents. So now I'm going to keep the base of x, and I'm going to add the exponents. 7 minus 2, or 7 plus -2, is 5. And you're going to go on to the next variable of y. This is a base because it has exponents, so I have y, and my exponents are 2 plus 3, which would give me 5. Let's try the next one. Here you have division going on, so this is going to be our quotient rule. Again, you divide the coefficients, just like you would with regular numbers, and then for the bases, you keep the base and subtract your exponents. So my coefficients are 54 and 9. 54 divided by 9 is 6. Then go on to the next part. Your base is s, and now I'm going to subtract your exponents. So 8 minus 2 is 6. Go on to the next one, the t, and you're going to get 5 minus 11 would give you -6. Oh, I didn't mean for them all to be 6. Anyway, the thing is, in this case, you have a base with a negative exponent. Now, typically, we don't really leave negative exponents in our answers, so you can see this rewritten in a different way. When you have a negative exponent, in order to make it positive, you're going to bring it to the opposite side of the fraction. So right now, technically, everything is over 1. So instead, you're going to take the t and you're going to bring it down below. And when it comes down below, it's going to become a +6 as your answer. Keep in mind that if you had a negative exponent in the denominator, like if you had 6s6 and the -6 on the bottom to begin with, you would move it up to the top to become 6s to the 6th power, t to the 6th power. Now, there is a zero exponent rule where anything to the 0 power is 1, but parentheses make a big difference in how you actually end up evaluating this. Now, in this case, everything is inside the parentheses, so everything becomes 1. In the next case, think about what's actually attached to the parentheses, attached to the exponent. Only the 2 is attached to the exponent. The negative isn't. So in this case, only the 2 becomes a 1, whereas the negative stays, because this can be really written as -1 times 2 to the 0. So keep in mind, parentheses really matter when it comes to exponents. Now for the last one, this incorporates a few rules. You have a few options when you have the power to power rule, like we have exponents on the inside of the parentheses and another exponent on the outside of the parentheses. You can either simplify what's inside first, or you can distribute that outside exponent into the parentheses first. Personally, I like to simplify the inside first. So to simplify the insides, the only thing you can really do with this is simplify the m's, because well, they're both m up top and underneath. So I'm going to keep everything in place except for the m's. Now with the m's, this is the division, right? It's the quotient rule. So 8 minus 3 is 5. It's positive 5, so I'm going to put m to the positive 5 up top. Now that you actually have everything taken care of, it's simplified inside parentheses, you can distribute that exponent on the outside with the power to power rule. Now, for the power to power rule, you're going to do a normal exponent with your coefficient. But when it comes to the bases, you're going to multiply the exponents together. For example, your coefficient is 3. All you're going to do is 3 squared. Now, for the next one, the m, you're going to multiply the exponents. So 5 times 2 is m to the 10th power. For the last one, the end, you're going to have n and multiply the exponents. 4 times 2 is 8. Now, you really are technically multiplying the exponents for everything, including the coefficient, because you can think of the coefficient as 1. And then 1 times 2 is 3 squared. The only way you can simplify this further is if you really want to write this as 9, if you actually do 3 squared, m to the 10th over n to the 8th. So here's a nice summary of all of your laws of exponents. Keep in mind that for negative exponents, when I say switch the position of the base, that means if you had your base with the negative exponent on the top of the fraction, you're going to bring it to the denominator. If you had the base with the negative exponent in the denominator, you're going to bring it up top to the numerator and then make the exponent positive. And that's all for this video.